Well, as you just heard, I'm Robin Vickery, and I'm a check penetration tester. I work for a company called Commerson based in Edinburgh, and we do normal penetration testing stuff. So we do check work, IT health checks, code and build reviews, internal and external penetration tests, and mobile and web application testing. And it's on the internal penetration test that we almost always come up with some kind of password cracking. It's usually because we've got access to some low-hanging fruit on the network. We've managed to grab a copy of the NTDS database on the domain controller, and we're either trying to audit the passwords for the client, or we're trying to track passwords, domain passwords to use on non-domain connected devices. So whichever we're doing, we usually do the same thing as pretty much everyone else does. We get a standard dictionary, rockq.txt is a favorite one, put in hashcat with varying rules depending on how much time we've got. So, my favorite is one rule to rule them all. Others use dive rule. Hobo 64 is a bit fast. And that gets us a rather large amount of passwords usually. People aren't very good with passwords. But in order to improve things a little more, what we need to do is start customizing the generic word lists to our customers. And I start off with some of my own word lists, which I've generally scraped from Wikipedia or the likes. I got a list of countries, cities, all the Scottish place names, all the Scottish surnames. Register Scotland provides a nice list of all the baby names for each year, and I stick all those in my password list, so my dictionary, and that gets us a load more. And because this is Scotland, I put in all the Scottish football clubs, all the football grounds, every player I could get off Wikipedia from the big four teams. And again, I guess it's another load of passwords. But after that, you have to start tailoring things for the specific client you're looking at. The normal thing you do is you start crawling the database using cool. It gives you a list of words which are related to that particular customer. You might want to crawl other websites which are in the same industry, so competitors, either regulator websites or other industry websites, to find other terms which are used within that company. And then you start using what I call common sense. You think about what the company does, and you try to think of what terms they might be using as passwords. So they're a transport company, and they've got a lot of lorry drivers, brands of lorries, rest stops, main roads. If they're a ferry company, you're looking for ports, ship names, nautical terms. If you look at where the company is located, if you're looking for any local landmarks, the history of the area, and you can go on. But the more time you're spending on this, the less time you're actually spending on doing the actual penetration test which you came to do. So what would be good is if we could automate a lot of this part of the work. And that's where I start looking at natural language processing, because natural language processing uses, one of the first things you do in natural language processing is you tokenize all the words in a text corpus, and you turn them into a form which you can manipulate. And that's done through something called word embedding, which translates every word that it finds in the text corpus into a big vector describing its relationship to all the other words that are in your corpus. So the way it usually works is you have a sliding window that moves across the text corpus. So, say, have 8 words within that window, and you count all words which co-occur within that window. And then you build up a matrix of those occurrences, and then you end up with a massive model that describes all the words. You then compress that down, getting rid of all the relationships, the words which aren't related to any other words, and you end up with a smaller but still quite hefty model. But what happens, what you find is that words which occur in a similar context in your training corpus also have vectors which are clustered together in the vector space. So here you can see all the kitchen items all clustered nicely over in there. So what we can do is you try to locate kitchen words is find all the words with a vector that are clustered quite similarly to, say, bathroom, and it will give you all of those. You also find that words have relationships that can be measured, that can be represented as part of the vectors. So if you'll find that the vector for a capital city and the vector for the country that it belongs to always have a similar distance between. So here we have the vectors between various countries and their capital cities, and you can see they're all pretty similar. And that also applies to other things. So there you go, the relationship between queen and king and man and woman are also pretty similar in terms of vector representation. So, in terms of generating these models, you don't really want to do it yourself, but luckily there's some big pre-trained corpuses that you can get, and they have trained these trained these models on publicly available text corpuses, which are those ones there. So the big one normally is the Wikipedia dump. We find most of the pre-trained models use that in some form or other. And there's the Newswire. There's a couple of ones which use Newswire data as well. And this is where you can get those pre-trained corpuses, also pre-trained models. In order to use them, we use a library called Gensen, which is a Python library. That's how you install it. It's all pretty simple. And it lets you load the models and work with them. And this is how you actually can import and load a model and then find the words similar to Edinburgh. So it's all pretty self-explanatory, actually. So that should return to us the 5 most similar words to Edinburgh. And this is what it actually comes out with. So on the left there you find the words, and on the right you have a float that ranges between 0 and 1 that represents the similarity to the original word. And here it's managed to find all of the cities, it's identified Edinburgh as a city, and it's given us lots of Scottish cities that are similar. The downside of that is that took 3 minutes and 21 seconds to run on my laptop. And in terms of using that to find other candidates for password cracking, that's not really acceptable. Luckily, most of that is upfront cost from loading the model and the initial search. So if you're actually searching for additional words on top of that, it takes roughly 3 seconds per word. So really, we don't really want to be doing this for every word. We want, well, don't want to be restarting this for every word. We want to be starting it once and chucking 8 words at it as a team. So we can also improve the speed by indexing. The indexers tend to reduce the accuracy, which, to be honest, I'm not that bothered about, and increase the startup cost. If we're doing this as a daemon, then the startup cost is not a big issue either. So this is the same thing with indexing. This uses the annoy indexer, and apart from adding the indexer, it's pretty much the same code, but you'll find the results are different from that. So here it's found Edinburgh has a perfect match, which is not a surprise. But the other results are slightly different. It's not coming back with Scottish cities, apart from Glasgow anymore. But they're all related in some way or other to Edinburgh. Is some matches for other words, so Lagavulin, which is a whiskey, so it's come back with other whiskies. A fish, and a type of car. It's all come back with various related words. So the next step from this is to put a wrapper around hashcat, and then we do an initial run of hashcat with the standard dictionary, and then it finds a bunch of words, of passwords. We then clean them up using fairly basic regular expression to remove all the bits and pieces people add to the end of their passwords to make them random. And we put the words into our GenSim script. It will output a whole load of similar words, and then we put those back in the dictionary, and we rerun hashcat with that. And we repeat until we get bored or it's not producing any new passwords. We can then reseed with different words if we want to, or we can leave it at that. And that is what I've got to so far. That's what I'm working on at the moment. So any questions?
Yes. Ask a question.
Yeah, sure.
So I guess it's kind of been a shift. So large organizations have different password policies now, so it's kind of pseudo-random type policies and passphrases or just combinations of different words. So how do you adapt more to deal with, I guess, simple obfuscations and just looking at natural language? Previously, people did simple substitutions, that sort of thing. If you've got passphrase, then you're not going to have your own substitution or permutation convention, which would break the model, because it would still be a word or a list of words that are very easy to remember. But you just do simple substitutions and you flip the last and first letters. Most people can still read that sentence.
Yes. So in terms of this won't have you much when you've got sentences, because this will find similar words. You can use the same techniques with n-grams. So you go rather than complete words, you use. So you can use the same technique with n-grams. So rather than complete words, you're using sections of words, and that has more flexibility. It's not. It doesn't require then to have your test, the sample word already in the model. It can find words which, how to explain.
So I took the passphrase apple, pear, orange, just chopped off the first and last letters, and concatenated them. This method would still work.
Oh no, this method. Well, if you took apple, pear, and orange, in order for this to have any kind of success, you need to split that up into apple, pear, orange again. There's techniques for doing that, which I'm actually planning on putting in this. But that would be an additional step. You'd have to split the password up, discover password up into alphabet orange. Then you've got alphabet orange, shove each individual word in the database, and then the rules would put them back in together again to match additional passwords. Does that sort of answer your question? Sort of.
Yeah, sort of.
Yeah. On its own, this won't really help with the situation you're describing. But an additional step to take a combined password and split it up before it goes into here will cope with that. Hey.
What clustering algorithm?
I'm just using Jensen's built-in. It's been so long since I've done any maths, so I'm just using what it provides. I'm not using anything special.
Do you use John the Ripper as well?
Sorry?
Do you use John the Ripper?
John, I did a long time ago, but I tend to use Hashcat all the time these days, and that's partly from familiarity rather than anything else. Anything else?
Based on there's about the alphabet orange scenario, you've got to know originally that is in fact going to be a password with those three elements.
Well, yeah.
Based on that principle, and presuming he's only using upper and lower case, as soon as you start interjecting any unusual symbols, should we say, you've added to that complexity.
Yes.
And again, it does your process take into consideration that type.
So you need to know, you need to find a password in there that has, say, apple, pear, orange. You then need to split that up into apple, pear, orange. Look for similar words, so it might come up with banana of a fruit. Yeah. And then your rules, your hashcat rule will then recombine words, random words, together to make other combinations. So it might come up with banana, orange, pear. That gets very complex very fast. So you have to limit the amount that you do, otherwise you're going to be there forever. And usually we're on a limited time for this. So, sorry, I lost track of the question.
I'm just thinking of the various complexities. Firstly, you don't know how many words phrase is in there, and I've just thought of a phrase here which would totally blow most things apart. It would be Scylla, Coral, and Plymouth. And for anyone who knows Plymouth, HMS Scylla was sunk just off Plymouth and it has become a reef. But to use those three words would surely throw your principle into...
So, you could probably split the you're unlikely to find Scylla, Coral, Plymouth, or related passwords originally in the first place. And this will only find passwords which are related in some form to ones which have already been discovered. If you did find through, let's say Scylla, Coral, let's say you got onto a machine and you loaded Minicats, Kiwi, whatever, and you found Scylla, Coral, Plymouth as a cached password on that machine, and you used that as one of the initialization passwords in your dictionary. Because you split it up into Scylla, Coral, and Plymouth, and it will almost certainly find words related to each of those words. They probably won't come up with any matches in any other passwords, because it will find Charybdis as a similar word to Scylla. It'll find, I don't know, Portsmouth as a similar word to Plymouth, and it will find anything. I can't think of something that comes up with coral at the moment, but probably pink as something similar to coral. But you put those words together, and it's very unlikely to match anyone else's password in the organisation. But it will find a lot of other things. So it's not there to help you to get every password. It's there to take a lot of the domain knowledge that you need to when you go into a client, and you're having to spend time trying to think of what they choose as passwords. What are the terms that are important to their industry, and you've got limited time, and you're trying to work on other things at the same time as this. And this is just to take out the requirement for you to actually be wasting time doing that rather than other things. Okay. Hello again.
What he said, so what you said also, so I have a password is a type call and Plymouth, and you said, of course, Plymouth will generate more things similar to other cities, but it would be very, very strange to see a password that was just Portsmouth, London. What heuristics can you make use of to reduce the incidence of redundant words, more or less?
So that's down to the rules you use for Hashcat. So this just provides a list of words for your dictionary. The rules which you provide Hashcat will govern how you combine them, and that's really up to you. I just tend to use a dive rule or one rule to rule them. But it's not really part of the natural language processing part. I can't think of any way to actually govern that without outside the rule, the list of rules.